This demonstration illustrates the integration that is possible between MillSoft's Dispatch OMS system, Hunt Technologies Command Center AMR system, and QEI's TDMS Plus SCADA system using Multispeak version 3 web services. We show how a dispatcher would use an outage management system to perform outage analysis and restoration using the following real-time multi-speak interfaces from a single platform: SCADA, AMR, interactive voice response, an outage management system, a weather data stream using standard OpenGIS data flows, engineering analysis, and a geographic information system. With all the data from the multiple multi-speak interfaces provided, the dispatcher can dispatch a crew to the most likely cause of the outage. In this demo, the outage is initiated by a SCADA status open event on a feeder breaker. The outage analysis system quickly alerts the dispatcher of the breaker that is out and all the customers affected. The dispatcher can use real-time fault current data from the SCADA system to analyze the suspected fault using the fault locator tool. The weather data displays several lightning strikes in the area of the suspected fault. Even before dispatching the crew, the dispatcher has a clear picture of what is causing the outage and how to isolate and restore as many consumers as possible. Thus, he can stage his crews in advance of the outage events so as to minimize the outage duration. As we begin our outage scenario, MillSoft's Dispatch outage management system is displaying a severe weather alert that appears as a ticker tape display on the lower screen just above the status bar. Doppler and infrared radar displays an actual storm that was recorded on the 14th of February 2005. Next, the dispatcher turns on the weather legend to display the lightning strike data. You can see that strikes are color-coded based on strike intensity in amps. Each strike can be displayed individually to show the time that the strike occurred. You can see a lightning strike happen right over us at Multispeakville, EMC. This is the SCADA one-line display of the QEI TDMS Plus SCADA system. We're looking at what happened just before the lightning strike occurred. The breaker that we're interested in is breaker 1141 on the far left. Notice the window labeled Multispeak Link to MillSoft. This window is used for the demonstration to clarify the web service's messages being exchanged between QEI's SCADA system and MillSoft's Dispatch OMS. Breaker 1141 has just turned green, indicating that the breaker has opened. You can also see in the Multispeak Link to MillSoft box that one SCADA status message and 3 SCADA analog messages were sent to the OMS. The status message indicates to dispatch that breaker 1141 had just opened, and the 3 analog messages show that the 3 phase currents on breaker 1141 have just dropped to 0, also indicating that the breaker opened. Let's go back to the outage management screen just before the breaker opens to see what occurred there. The outage tree view on the left displays an unassigned outage on feeder breaker 1141 with 218 customers reported out. The dispatcher zooms in to the suspected outage on the map and turns off the infrared radar for a clearer picture of the outage in progress. By zooming in on several lightning strikes, the dispatcher notices several strikes as high as 300 amps in the vicinity of a line section. The dispatcher turns off the weather layer entirely and notices the blue phone symbols representing IVR calls and red Hunt turtle icons indicating AMR outages right at the consumer locations on the dynamic graphical display. He can highlight the location of the lightning strikes on the system map, showing a likely location for an outage. The Dispatch Outage Management System uses Color by Outage mode to display a verified open in red downline from the feeder breaker that SCADA reported as being open. An outage ticket on the feeder breaker displays a total of 218 customers out of power. Hovering over any customer displays a hint text box right on the map that displays the customer's name, phone number, map location, service address, and if a priority customer, the type of priority. Since this outage event came from the SCADA, the outage predictions are bypassed, allowing the outage analysis to confirm the outage automatically. The dispatcher double-clicks on the outage tag, which displays the circuit element navigator. The dispatcher can display the real-time SCADA results reported by QEI's SCADA system. 0 amps are displayed because this breaker is open. The dispatcher selects the SCADA device status tab and presses the Read SCADA Status button to confirm the open status. The dispatcher then selects the SCADA Fault Currents tab, which displays the recorded fault currents for this breaker. The dispatcher presses the Read SCADA Fault Currents button to retrieve in real time the actual fault currents. Using these fault currents, the dispatcher presses the Run Fault Locator button to invoke the Fault Locator Analysis dialog. The dialog displays where the fault is measured from and the tolerance, 2%, that the dispatcher wants to apply for the fault locator engineering algorithms. The analysis quickly predicts a possible fault at line section 3470. And the editor selects this line section so the dispatcher can see the phase, impedance length, and type of conductor on each phase. The graphical display selects the line section in yellow to display the location of line section 3470. The dispatcher pans and zooms to this location. Dispatcher then presses the Outages button, which displays the Outage Manager. It shows the verified SCADA breaker outage in more detail. The Outage Manager displays the number of customers out initially, the number of customers that called, and the percentage of customers that called. The dispatcher then selects the Calls Received tab to display all the customers that called in for this outage. This tab displays all the details for each customer. The dispatcher then selects the Customers Affected tab to display all of the customers that are part of this outage. The dispatcher then selects the Sensor Records tab to display all outage detection devices that have confirmed power off. The dispatcher then assigns a crew to the outage. Equipped with the results of the fault locator, the truck proceeds directly to the location of the fault. The crew reports in to the dispatcher to confirm that lightning struck one of the poles, causing the fault at line section 3470. They quickly isolate the outage and report to the dispatcher so that he can reclose the feeder breaker. The dispatcher records the temporary break on line section 3470, which changes the color of all elements downline from the break and restores the feeder breaker. The time of restoration is recorded. SAIDI and CAIDI indices are automatically maintained by the inputs from the dispatcher and the SCADA. The outage tag now reflects a partial restoration up to the temporary break and reflects 156 customers still out of power. The circuit color changes to reflect the restoration, and the blue IVR calls disappear to reflect that the automatic callback process is initiated. The AMR icons also disappear to indicate the restoration. A short time passes and the dispatcher notices that the Hunt Turtle icons have changed to green, confirming the successful power restoration. The dispatcher confirms this by displaying the Outage Manager Sensor Records tab to view the AMR records that have confirmed restoration. The records change to green and the Confirmed On checkbox is selected. The dispatcher then checks the sequence of events that have occurred by pressing the Edit Outage button. Next, the dispatcher selects the Sensor Records tab to see if all AMR meters have confirmed restoration. While at this tab, several more meters confirm. The dispatcher notices that 2 meters have yet to report restoration, but the dispatcher does not need to worry about this because dispatch will alert him automatically if any meter does not confirm power restoration within a given time frame. The dispatcher then records when the temporary break was restored and the display reflects the complete outage restoration. Next, the dispatcher selects the Outage Cause Codes tab to enter the cause of the outage and then closes the outage. The entire bookkeeping was handled automatically by the dispatch system. A few moments later, the dispatcher is alerted by the audible and flashing outage alarm that a new secondary outage has appeared. Out of the 2 AMR meters that did not report power restoration earlier, 1 failed to report in. A predicted outage tag appears on transformer TR7477, reporting 2 customers out of power on phase A. The outage start time continues where the outage was thought to have been restored. The dispatcher selects the Sensor Records tab in the Outage Manager to confirm that the problem meter is still reporting out of power. This all occurred automatically using the Multispeak real-time interface.